In 1973, the Burlington County Mosquito Commission began using helicopters in a very aggressive adult and larval control program with the lease of a Bell Model 47. 18 years ago, the 47 was considered the standard in the aerial application industry, and in many parts of the world still is today. In 1977, the year I started with the commission, we began operating our own Hiller UH-12E helicopter, acquired through military surplus channels and rebuilt the previous year. During the next 4 mosquito seasons, I flew this aircraft over 1,000 hours. The program proved immensely successful despite this 17-year-old 6-cylinder aircraft's seemingly excessive maintenance requirements. During those 4 years, the Hiller was grounded nearly 25% of the time for unscheduled maintenance. It was precisely for the reasons of improved reliability, maintainability, and efficiency that in 1980, Burlington became the first New Jersey county to own and operate its own turbine or jet-powered helicopter with the purchase of this Bell 206B Jet Ranger 3. The aircraft is easily transported between the hangar and the helipad or launch area aboard this mobile landing platform, powered by an 11-horsepower garden tractor. The Jet Ranger has ample power to hover with a full load of pesticides on the hottest July and August days. We operate out of a couple of acres here just south of Mount Holly. We're bounded on 2 sides by apartments and condominiums, and on a 3rd side by new single-family, moderate-income homes. The fact that we've never had a complaint since we've been operating out of here says a lot for the low noise signature of the Jet Ranger. We're going into our 10th year with this aircraft, and I honestly can't say enough nice things about it. It was a major purchase for the commission, but support for the acquisition was unanimous from the freeholders and commissioners on down. The Jet Ranger is a relatively agile and maneuverable machine. Its 1,500-pound useful load, as well as its obvious speed advantage over the Hiller or Bell 47, is what originally attracted us to this aircraft. But once purchased, other peripheral advantages became obvious. Excellent forward visibility, ample instrumentation for engine, transmission, electrical, fuel, and hydraulic systems monitoring, as well as the placement of flight controls and the ease of handling the aircraft. Burlington County, being near sea level and very flat, as evidenced by the large number of cranberry bogs within our borders, also plays host to several thousand acres of salt marsh. This requires frequent landings and takeoffs from these often flooded meadows for the purpose of mosquito breeding area inspections. The aircraft handles this quite well. As promising for our needs as this aircraft was when purchased in 1980, the Jet Ranger was still relatively new to mosquito control. As a result, there was very little aerial application equipment specifically designed for the aircraft that was commercially available. Consequently, we had to design and build a granular dispersal system tailored to our particular needs. The larvicide system that we developed for our Jet Ranger incorporated an internally mounted pesticide hopper. This design offered many advantages, as well as one particularly inconvenient disadvantage. It restricted access to the top of the hopper for loading. We overcame this limitation by incorporating a side-mounted loading door. While this met our immediate needs and worked quite well over the years since we've owned the ship, we've always recognized the potential for improving the loading process. The dusty procedure of loading the aircraft with abate granulars from 25-pound bags required the loader to suit up with gloves, goggles, and respirator. It also required the aircraft to be shut down for loading. To fill the voids on the far side of the hopper, the loader used a broom and a bit of elbow grease, as my able assistant Bill Keebler here demonstrates. To overcome these limitations and reduce the environmental impact of our operation, a feasibility study was conducted. The research and development phase of this study indicated that a closed loading system, such as those associated with liquid pesticide handling equipment, seemed to be the way to go. The simplest method we could devise to transfer pesticide to the aircraft hopper involved 3 components mounted to a small trailer, as is shown here. Those components are a holding tank, a blower to supply the propulsion, and hoses through which the pesticide passes. We experimented with a variety of air-moving devices and finally decided on a powerful unit manufactured by a Pennsylvania company by the name of Emerand McKissick. It's actually designed to be used as a tailgate-mounted leaf vacuum and is available in 8 and 11 horsepower. We modified the 8 horsepower model to discharge the air horizontally instead of vertically. This air blast is produced by an impeller mounted to the output shaft of the Briggs & Stratton engine. This impeller draws air in from the side. Unlike its original purpose of vacuuming leaves, we use it to draw air out of the helicopter hopper. Before the engine is started, 2 4-inch transfer hoses are attached to the helicopter chemical hopper. They incorporate quick disconnect cam lock fittings to facilitate the hookup. The engine is then started. As 2,000 cubic feet per minute of air moves through the system, gravity dumps the abate 5CG into the airstream. The granule pesticide is carried through the hose on the left and deposited in the aircraft hopper. Granule-free air returning from the hopper then exits through the hose on the right and is drawn back into the vacuum side of the blower. As the aircraft hopper fills with pesticide, the air being displaced inside had to be transferred to the void being left in the trailer-mounted tank as pesticide flowed out. This is accomplished by incorporating a PVC vent tube running from the blower output line to the top of the trailer tank. One of the doubts that haunted us throughout the design and construction phase was, would the blower be powerful enough not only to elevate the pesticide to the top of the helicopter loading port, but also propel it once it left the hose to the opposite side of the hopper and fill all voids? 2 final tests remain that would confirm or deny our doubts. The first test involved loading a sampling of blank Celatom granulars, the carrier used in abate 5CG, into the trailer-mounted tank to see how far the material would be propelled once it left the hose. As can be seen from this demonstration, the results were encouraging. The second test involved actually transferring 500 pounds of Celatom from the trailer to the helicopter hopper. As shown here, the helicopter hopper is raised with a forklift, duplicating the exact height differential that would be encountered in an actual loading situation. The blower engine was started and allowed to run at full throttle. Some minor leaks were noted in this otherwise airtight system and later sealed with silicone sealant. Celatom could be seen coursing through the semi-transparent flexible plastic hose. Approximately 12 minutes later, a distinct change in audible pitch was heard from the engine, and the Celatom had stopped flowing. The inspection cover on the helicopter hopper was removed, and we were all relieved to see the granular material packed clear to the top. Technically, the project successfully ended here, but we wanted to take it a step further and address the problem of the dust left in the trailer tank, as well as the dust created while reloading the trailer tank. We solved both with an industrial dust collector and a large capacity filter bag. This, attached to the loading hose, drew dusty air out of the tank through the vent pipe, and instead of dust blowing up into the loader's face, it was drawn down into the tank and out through the vent. An alternative method of utilizing this loading system, and one that we prefer, involves mounting the entire trailer, less the wheels and axle, on the back of a pickup truck. We find that it's more maneuverable than towing and backing a trailer, and the additional height is not a problem since we always fuel and load the aircraft while it's on the mobile landing platform. On a routine day, after applying a load of pesticide, I would land and signal my ground crewman, Bill Keebler, to approach with the truck. After the hookup was made and the loading process begun, Bill would be free to begin fueling the aircraft as soon as the engine was shut down. If fuel was not needed, the aircraft would remain running during the pesticide loading operation. It is especially important to ensure that the helicopter is well grounded during all fueling operations, since the rapid movement of the pesticide through the loading system creates considerable static electricity. This year, 1991, is the first year that we will be using this loading system. Hopefully, it will benefit our productivity, the environment, and the residents of Burlington County.